Welcome back. Today we will be talking about inverse functions. And inverse functions, we write the notation as f to the power of -1 x. And this is not power as -1, it is the way you write the inverse function. So this is called the inverse of f of x. Now what does that mean? It means f inverse x is set of all points in the coordinate form y and x. Yeah, it is a little different, right? Whereas for x and y, we take the coordinates as x and y. So what it implies? It implies when we are talking about the inverse function, we are swapping x and y. So inverse functions are nothing but it switches the domain and the range. So for the original function, the domain is x and y. For the inverse function, it will be y and x. Let's understand it. One important thing about the inverse function. So the notation for the inverse function is f -1 x. This is not equal to 1 over f of x, because till now you have learned that a to the power of -m will be 1 over am, right? The basic exponent property. But this is different when we are talking in terms of inverse. They are not equal. It is just the notation of writing the inverse. So for example, if the parent function or the initial function is 2 comma -3, then its inverse will be -3 comma 2, because we are just swapping or switching x and y, the domain and the range. Now how to prove that the two functions are inverse? So to prove that the two functions are inverse, we have to follow a rule. And please watch it carefully. It is easy, but you need to be a little bit careful. So we have f of x and f inverse of x, and let's f inverse of x is g of x. So we are defining the inverse function as another function. And f and g of x, they are inverses of each other, right? So how can I say we can write in the combination function. So the combination or the composition function you have discussed in 2.6. So we can write in the composition function something like this, and these two composition functions, they should be equal to x. So how can you read the first function? This is nothing but f composed with g. This is x, or g composed with f will also be x. If this condition is met, then we can say the two functions are inverses, right? So f composed with g or g composed with x should generate only x. Let's understand with one example. In this example, we have f of x as 2x plus 3, and we have another function g of x as x minus 3 over 2. Now g of x is, we are saying that it is, are these two functions inverse of each other? And how we can prove that they are inverse of each other? By writing the composition function. So let's write them down. So we need to prove they are inverses. So to prove, let's write down f composed with g. That's my first composition function. So f, what is g of x? G of x is x minus 3 over 2. Now, x minus 3 over 2, this is your new x. And we will plug it in f of x. New x. It is a good idea when you are trying these questions. Make a note for yourself. It is new x. It is just like training your brain. I need to plug the x as new x. Because f of x is 2x plus 3. Instead of x, you will plug new x, which is x minus 3 over 2. And if you solve it, you will get x. I will do the same thing with g composed with f. And if g composed with x also gives you x, as the answer, that implies that f of x and g of x, they are inverses. Now this is 2x plus 3. This is your new x. And you will plug new x in gx function. So g of x function is x minus 3 over 2. So instead of x, we are plugging 2x plus 3 minus 3 plus over 2. And this also generates x. So this implies that f of x and g of x, they are inverses. Basically, f of x and g of x, they undo each other, because that is the beauty of inverses. We will try to see how it looks graphically. And I wrote HB, that implies hence proved, because they are asking us to prove. Now it is your turn. Try one question on your own and try to prove if the two functions are inverses, yes or no. So the parent function or the initial function is and we have two different questions under it. Question number A is g of x is equal to So basically you are trying to prove if f of x and g of x, they are inverses, and you will also try to prove if f of x and h of x, they are inverses. So follow the same process, f composed with g and g composed with x. If it gives you x, then they are inverses. Let's understand it through this diagram. What are inverses? So if you look at the domain of the function x, right, and the f of x, which is the inverse. So basically, we are changing the domains and the range of the function. So f of x, the domain and range for inverse, the domain of f of x will become range, and the range of f of x will become domain for the inverse. And there is another important thing that is called the horizontal line test. Horizontal line test will help us to determine whether we have the inverse function. This is how the inverse function looks like. The top graph is f of x and the bottom graph is f negative 1x. That means it is inverse function. And we have y is equal to x line. And if you see the 2 points, a, b are swapped with b and a. So this is very, very important. In a horizontal line test, till now, for a function to be a valid function, we have done the vertical line test, right? Now the horizontal line test, this is a test that gives us the surety that the functions are inverses or not. So it says if and only if it is only no horizontal line intersects the graph at more than 1 point. So in the first function, that function is a cubic function, and the horizontal line, it touches the graph only at 1 point at one time. But the second function, it is a square root function, and the same horizontal line is intersecting the graph at 2 points. So the quadratic function is not does not satisfy the horizontal line test, but the first one satisfies the horizontal line test. And the another thing that is mentioned in the lines is the one-to-one function. So one-to-one function means for every x value, we have only one y value. We are not looking for two different y values. So 1 to 1, 1x, 1y, right? So if no horizontal line intersects the graph of f at more than 1 point, we can conclude that f is one-to-one function and does have an inverse function. If it is not a one-to-one function, that means it does not have the inverse function. So this is my checkpoint. So how will you read this? F composed of inverse is equal to x, or inverse composed of f of x is also equal to x. The same thing that we use to prove that the functions are inverse. Now again, we are talking about the functions. And when we talk about the functions, we take into assumption that that the equation is a function. And the equation will be a function only and only if it satisfies the vertical line test. Isn't it? So let's write down how to calculate or how to find out the inverse function more algebraically. So first step, switch x and y. Second, solve for new y. So these are the two steps that will help us to write a new function that is the inverse of the original function. Now, as I discussed, for an equation to be a function, it should satisfy the vertical line test. This is my prerequisite. Now, if it is a function and if it has the inverse function as well, then we need to check horizontal line test and one-to-one function as well. So vertical line test, it satisfies. But for having an inverse, it needs to satisfy two conditions, horizontal line test and one-to-one function. Right? So don't get confused about the vertical line test or horizontal line test. Vertical line test is a prerequisite for a function to be a function. Okay. Let's take one example. So the example wants find inverse, and the function is x cubed minus 1. Now let's analyze what is given to us. It is x cubed. It is cubed, right? So it is a cubic function. And a cubic function, it looks like the S shape, right? It has a transformation of minus 1. That means it is going down 1 unit. It passes the horizontal line test because on a horizontal line test, it will intersect the graph only at 1 point. And cubic function is also a one-to-one function. So these are the analysis from the given function. Once I know what is the analysis, once I know that it satisfies the horizontal line test and one-to-one function, let's find out what is the inverse function. So step number 1, switch x and y. So we have y is equal to x cubed minus 1. If I rewrite it, it will become x is equal to y cubed minus 1. Second step, it says solve for new y. So let's write down the function again, the new function. That means after we rewrote and solve for y. So y cubed is x minus 1. This implies y will be cube root of x minus 1. So this is what we got, the inverse function of f of x. So therefore, f inverse is cube root of x minus 1. Right? So few takers, horizontal line test, one-to-one function to prove that it is inverse function and to write the inverse function. Now it is your turn. Try one question for me and practice. So find the inverse of, I am giving you two questions. F of x is equal to, and the another problem is f of x is equal to cube root of 10 plus x. So this was my analysis for the inverse function. Keep on practicing these questions and I will see you with chapter 3. Bye-bye.